All right, let's dive right in. Have you ever wondered how we teach a computer to actually read? I don't just mean recognizing letters on a screen, but really truly understanding human language. Well, it all starts with one absolutely critical first step. Just picture this for a second. It's Monday morning. You open up your laptop and bam, there it is. You're staring at an endless email chain. You know the one. 20 different replies, forwards with all sorts of crazy formatting, and all you really want is a simple summary. And that's the big question, isn't it? Before a machine can do anything cool like summarize that email or translate it, it has to somehow make sense of all that raw, messy text. So, how can a computer even begin to read something so chaotic? This is the fundamental challenge of natural language processing, or NLP. To get our heads around this, we're going to look at a real-world example, a huge data set of actual email threads, which also came with summaries written by humans. This is perfect, because it gives us both the messy stuff we need to clean up and the perfect after picture to aim for. And we are not talking about a few dozen emails here. The dataset we're working with has 21,684 raw emails in it. Just imagine trying to process all of that by hand. It gives you a sense of the massive scale of the problem we're trying to solve with a machine. So how do we tackle it? There's a brilliant metaphor for this whole process. Think of understanding language like peeling an onion. You can't just slice right to the center to get the meaning. You have to go layer by layer. And these are the layers of that onion. You start with the tough outer skin, which is lexical processing. It's all about the words themselves. Then you get to syntactic processing, which is grammar. Go a little deeper and you hit semantic processing, what the words actually mean together. And right at the core, you finally get to the good stuff, like summarization. For today, we are going to focus only on that crucial outer layer. So what exactly is lexical processing? Honestly, think of it as the ultimate prep work. It's like tidying up a super messy room before you can actually find anything. It's all about taking that raw, jumbled text and transforming it into a clean, consistent format that a machine can actually understand and work with. And that brings us to our very first job, the big text cleanup. The technical term for this is text normalization, and it's all about one thing, making the text consistent and just getting rid of all the junk. And wow, there is a lot of junk to get rid of. First, we make everything lowercase, so the and the are treated the same. Then, all those website links and email addresses, gone. Those endless quoted replies that stack up in a chain, we strip them out. Same for the email headers and signatures. And finally, we get rid of all the weird extra spaces. It's basically like power washing the text until only the important stuff is left. And check out the difference. On the left, you've got that typical email mess. Dates, names, links, all that formatting noise. But after normalization, look at the right. It's just the clean core message. All that other clutter has literally vanished. It's so much simpler. Okay, so our text is sparkling clean. What's next? Well, now we have to break it down into useful little pieces. This is called tokenization. It sounds fancy, but the idea is super simple. We just chop up that clean text into its basic building blocks. First, we split it into sentences, and then we split each sentence into individual words, or tokens. So now we have a big, long list of words. But we're not quite done yet. The next step is to refine this vocabulary even more. We want the machine to focus only on the words that carry real weight, not all the little words that just kind of glue the sentences together. And the first things to get the boot are called stop words. These are the most common words in English. Words like the, is, at, a. You see them everywhere, but they don't really tell you what an email is about. So by yanking them out, we cut down on the noise and help the machine really zero in on the words that matter. All right, we've filtered out the filler words. But here's a new puzzle. What do we do about different forms of the same word? To us, study, studies, and studying are obviously related. But a computer, it sees them as three totally separate, unique words. So how do we teach it to see that connection? We have two main tricks for this, stemming and lemmatization. Check out this table. Stemming is kind of the brute force approach. It just crudely chops off the end of a word. So studies becomes study. Pleased becomes please, which isn't really a word, but lemmatization is much smarter. It uses a dictionary to figure out the root form of the word, its lemma. So studies becomes the actual word study, and terminated becomes terminate. It's way more elegant and gives us a much cleaner result. Okay, we are so close. Our vocabulary is lean, it's consistent, But there's one last little problem that pops up all the time, especially in emails: typos. So it's time for one final polish. Yep, we have to correct all those misspellings. Machines can actually get pretty good at this. They calculate something called edit distance, which is basically the number of little changes it would take to turn a typo into a real word. And then they pick the most probable correction. So spelling becomes spelling, and Python becomes Python. Pretty clever, right? So let's just take a step back and look at the journey. We started with a total mess, a chaotic, raw email. We put it through this whole cleaning pipeline. We normalized it, tokenized it, filtered it, and corrected it. We've literally gone from chaos to clarity. But was all that effort actually worth it? Oh yeah, the data tells the real story here. Take a look at this. This chart says everything. Before any processing, the average email was over 3,000 characters long. After just that first normalization step, we cut the length in half, down to about 1,500 characters. That means the data is so much smaller and dramatically more efficient for a machine to handle. And this is why it all matters so much. This clean, standardized text isn't just a nice little improvement. It is the essential fuel for every single advanced NLP task that comes next. You simply cannot do things like summarization or topic modeling on messy data. Lexical processing is the absolute, non-negotiable foundation for everything else. So, we have a clean list of meaningful words. That's great, but a list of words isn't a language. How does the machine learn the rules, the grammar, that connects them all together? How does it figure out a noun from a verb? Well, that is the next layer of the onion, and that's a story for another day.